Most debates about aircraft carriers begin at the moment of missile impact. That framing is too simple. In the real world, major military systems begin to fail long before the dramatic strike that makes headlines. Sometimes they fail because the picture goes dark. Sometimes they fail because the support chain starts to choke. This briefing looks at both failure paths together. First, what happens when a carrier temporarily loses the eyes and confidence that make its defensive system work? Then, what happens when the same carrier group is pressured through fuel, maintenance, replenishment, and industrial dependence instead of through a cinematic killing blow? What happens when a $13 billion carrier loses its eyes for 7 minutes? Not its engines, not its weapons, not the flight deck, its eyes. For 7 minutes, the ship that is supposed to see farther than the horizon becomes a giant piece of steel, moving through the dark with less certainty than the people standing outside with binoculars. That is the scenario in this briefing. This is not a claim of leaked classified access. It is a reconstructed operational failure chain built from public naval procedures, public reporting about radar and combat system dependence, and the logic of how a carrier strike group protects itself. The point is simple. People talk about carriers as symbols of power. They talk about catapults, fighter jets, nuclear propulsion, and the cost of the ship. What gets less attention is how dependent that power is on uninterrupted awareness. A carrier does not survive because it is big. It survives because it sees threats early, sorts noise from danger, hands the right track to the right system, and keeps that picture stable while the formation is moving. Take that picture away, even briefly, and the problem stops being cinematic. It becomes mathematical. How fast can the ship rebuild the track picture? How much of the escort screen can compensate? Who knows the outage is real? Who is still acting on stale data? And if an inbound weapon is already inside the envelope, how many of those lost seconds can the group afford to understand why 7 minutes matters? Stop thinking of the carrier as one ship. A modern carrier strike group is a moving network. The carrier is the center of gravity, but the defensive picture around it depends on sensors, links, radars, operators, doctrine, and timing. The outer layer may come from aircraft, escorts, and shared tracks. The middle layer comes from shipboard radar, combat systems, and controller sorting contacts. The inner layer is the short timeline where identification becomes engagement and engagement becomes survival. In theory, redundancy solves the problem. If one sensor drops, another picks it up. If one console goes dark, another team sees the same picture. If one ship loses clarity, the escorts fill the gap. That is how the architecture is supposed to work. In practice, outages are rarely clean. Real failures arrive as chains. A power fluctuation causes a reset. A reset causes one array to drop. The software picture lags behind hardware recovery. A data link keeps forwarding old track logic for a few moments after the local source is gone. Operators spend precious seconds asking the most dangerous question in naval combat. Is this a real casualty, or is this only a display issue? That distinction matters because navies train constantly around the possibility of bad data. False returns happen. Ghost tracks happen. Friendly tracks disappear and reappear. A technician can see one thing, a tactical action officer can see another, and the bridge can still believe the system is healthy because no one has yet fused the evidence into one plain warning. So walk through the 7 minutes. Minute 0. The ship is operating at night. Aircraft movement may still be underway, or the deck may be recovering from a launch cycle. Inside combat information, the watch team is settled into routine. The radar picture is noisy but normal. Escorts are in position. Controllers are balancing surface contacts, aircraft, friendly tracks, commercial clutter, and the constant work of maintaining a clean tactical picture. Then a fault appears. Maybe it begins as a short power event. Maybe a cooling problem causes a protective shutdown. Maybe a networked component in the combat system freezes and stops passing clean track data. The exact trigger matters less than what follows, because the dangerous part is never only the first failure. The dangerous part is the argument between systems over what is still true. At first, nobody outside notices. The ship is still moving. The radios still work. Bridge lights still glow. From the flight deck, nothing dramatic has happened. But in the combat system, something essential is broken. The picture is no longer trustworthy. This is where seconds disappear. A technician checks whether the loss is local to a display. Another operator attempts a refresh. Someone asks whether the feed is frozen or dead. A supervisor wants confirmation before declaring a system casualty to the rest of the group. Those are rational actions. They are also expensive actions when time is short. Minute 1. Now the watch team understands that this is not a single screen issue. One or more key feeds are gone or degraded. The ship may still be receiving partial data from other nodes, but confidence in the overall picture has dropped sharply. That does not always look dramatic. Sometimes it looks deceptively manageable. A few tracks remain. Some layers are still visible. The plot has not gone completely black. That can be worse. A total blackout is obvious. Partial blindness invites hesitation. If the display still shows enough to feel usable, people are tempted to work through it instead of immediately shifting into casualty procedures. That instinct is human and dangerous. Partial awareness does not only reduce information, it distorts decisions. A threat track that should be prioritized may now look intermittent. A clutter return may be mistaken for a valid contact. An escort might call out a track that the carrier cannot confirm on its own console, creating friction at exactly the moment when the team needs clarity. Minute 2. Word is moving now, but not evenly. Combat knows there is a serious problem. Engineering may know there was a power or cooling event. The captain may know that a key sensor is down, but not yet how wide the effect is. Escorts may receive a warning that the carrier is degraded, but the wording matters enormously. There is a difference between radar casualty, partial track degradation, combat system instability, and lost local confidence. Each phrase carries a different operational meaning. Each phrase changes how other ships act. If the warning is too soft, the escorts may not shift posture fast enough. If the warning is too hard, the group may overreact and create new risks. Command language has to be both accurate and fast, and those two demands pull against each other. This is the first tactical trap. The crew wants certainty before sounding the alarm. The timeline wants action before certainty is possible. Minute 3. Now the formation is compensating. Escorts are pushing their own picture harder. Controllers are asking for confirmation. The carrier may be trying to rebuild the local track picture while still receiving external information. The bridge is waiting for a clean explanation. The command team is deciding whether to treat the outage as a maintenance casualty, a tactical degradation, or the first sign of a larger attack. That difference matters. If this is only a technical fault, the group can manage it, recover, and document the failure. If this is the opening move of an attack, every second spent treating it as maintenance is a gift to the attacker. The hardest combat decisions often happen before anyone can prove they are combat decisions. Minute 4. The ship is trying to return to normal, but normal is not a switch. A sensor can come back before the picture is trusted. A display can refresh before the operators believe the track quality. A data link can show contacts before the command team knows whether the underlying source is stable. Recovery is not the same as confidence. This distinction is easy to miss from the outside. People imagine a radar failure as lights off, then lights on. But the real problem is not only visibility, it is trust. Can the watch team trust the track age? Can they trust the classification? Can they trust that two symbols on two screens are the same object? Can they trust that a track that vanished and returned did not move farther inside the defensive envelope while the system was blind? Every one of those questions eats attention. Minute 5. The larger formation is now living with the consequences. Maybe the escorts have carried the defensive picture well. Maybe aircraft have extended awareness. Maybe communications discipline has kept the group from becoming noisy. Maybe the captain has already shifted posture and made the right conservative call. Or maybe the group is still behind. If an inbound missile was already in motion before the outage, 5 minutes can be a lifetime. Modern defensive timelines are not generous. The farther out a threat is detected, the more options the group has. It can classify, assign, maneuver, queue, coordinate, and engage with layers. The closer the threat gets, the more those choices collapse. Long-range defense is about options. Close-range defense is about seconds. A carrier group can have extraordinary weapons and still lose value if the track picture arrives late. Minute 6. The technical team may be close to restoring the missing layer. The watch team may now understand what failed. The escorts may have assumed more of the burden, but the damage to the timeline has already happened. This is the part that makes the scenario uncomfortable. Even if the system returns, the lost minutes do not come back. The ship may recover the sensor. It may rebuild the picture. It may log the casualty, brief the captain, and continue operations. But if the outage happened during the wrong 7 minutes, the tactical cost may already be irreversible. Minute 7, the picture stabilizes. The system appears usable. The formation has adjusted. People breathe again. And now the investigation begins. What exactly failed? How long did each layer remain degraded? When did the watch team know? When did the captain know? When did the escorts know? Which decisions were delayed? Which assumptions were wrong? Which procedures worked? Which reports were too vague? Which displays looked alive but were not trusted? Those questions matter because a carrier strike group is not only a weapon, it is a decision machine. When the decision machine loses sight, the failure is not only technical, it is organizational. There's another layer that makes this worse. The carrier is not only defending itself, it is also making decisions for everything around it. Every aircraft in the pattern, every escort holding station, every helicopter waiting for tasking, every controller watching a section of sky, and every commander trying to understand the next move depends on a shared sense of what the group knows. When that shared sense weakens, people do not simply stop acting. They continue acting with partial confidence. That is the dangerous middle ground. If everyone knew instantly that the picture was blind, the formation could shift into a hard emergency posture. The escorts could assume wider responsibility. Aircraft could be moved, held, recalled, or redirected. Communications could become blunt. Command could say, treat the center as degraded until further notice. But real breakdowns often pass through ambiguity first. The display is frozen, but another display is alive. The local track is missing, but the link still shows something. The radar reset is underway, but nobody knows whether the data coming back is complete. The bridge hears one report, combat hears another, and engineering is still tracing the physical cause. That ambiguity is where attackers try to live. They do not need every defender confused. They need enough friction to slow the first correct decision. They need a few operators to ask for confirmation when the better answer would have been immediate action. They need the people with authority to wait for a cleaner picture while the timeline keeps moving. In a clean diagram, the kill chain has boxes: detect, track, classify, decide, engage, assess. In a real command room, those boxes overlap. They fight each other. A track can be detected but not trusted. It can be trusted by one ship and doubted by another. It can be classified too late. It can be engaged only after the decision authority catches up with the data. It can be assessed only after the next threat is already entering the same channel. That is why sensor continuity matters so much. The system is not just preserving information. It is preserving confidence. Confidence is what lets a watch team move quickly without turning every action into a committee. Confidence is what lets an escort pass a track and expect the rest of the formation to understand its weight. Confidence is what lets the commanding officer approve a defensive action without spending the next 20 seconds asking whether the display is lying. When confidence drops, the formation still has weapons, it still has trained crews, it still has doctrine, but every action costs more attention, and attention is a limited resource. During a 7-minute outage, the crew is not only fighting a technical casualty, they are fighting workload. They are fighting the mental pressure of uncertainty. They are fighting the need to preserve normal operations while preparing for abnormal consequences. They are fighting the fact that not every person in the chain learns the truth at the same instant. This is one reason navies drill casualties so relentlessly. The drill is not only about knowing which switch to throw, it is about compressing the time between confusion and procedure. It is about making the first report plain enough that everyone understands the operational meaning. It is about training people to stop admiring the problem and start moving the formation into degraded mode before the analysis is complete. Because in combat, the first perfect explanation usually arrives too late. The better question is not, what exactly failed? The better question is, what can we no longer assume? Can we still assume the local radar picture is current? Can we still assume the carrier can validate what the escorts are seeing? Can we still assume the flight deck is protected by the same reaction timeline it had 5 minutes ago? Can we still assume the commander is looking at the same threat picture as the watch team? Every no changes the posture. Every maybe should change it too. The hard part is that changing posture has costs. You can tighten emissions discipline and lose some information. You could push aircraft away from the ship and complicate recovery. You can hand more burden to escorts and saturate their own watch teams. You can elevate alert levels and burn fatigue, fuel, and attention. You can treat a possible threat as real and risk misreading the environment. None of these choices are free. That is why a 7-minute blindness event is not only a technical story. It is a command story. It is a story about how fast a military organization admits that the expensive center of the formation is temporarily weaker than the doctrine expected it to be. The most uncomfortable part is that the enemy does not need to know the exact cause of the outage to exploit the effect. If the effect is visible in behavior, it can be studied. If aircraft patterns change, that is a signal. If escorts tighten formation, that is a signal. If communications spike, that is a signal. If emissions shift, that is a signal. If the carrier reduces one kind of activity while another ship suddenly takes more of the burden, that is a signal too. Modern warfare is filled with these second-order clues. Not every sensor is trying to see the ship directly. Some are trying to see the formation react. Some are trying to measure hesitation. Some are trying to identify which node becomes dominant when the center is degraded. Some are trying to learn whether the strike group becomes louder, quieter, tighter, wider, faster, or slower under pressure. That is why even an accident can become intelligence. An accident reveals recovery habits. An accident reveals communication discipline. An accident reveals whether redundancy is only written in architecture diagrams or actually usable under stress. An accident reveals how much of the battle network depends on trust that nobody notices until trust is interrupted. And if a real adversary can observe enough accidents, drills, maintenance windows, and degraded mode behavior, they can build a playbook without ever receiving a classified manual. They can ask what breaks first, what takes longest to recover, what language appears when the crew is uncertain, which escorts compensate, which aircraft are held back, which systems come online first, which decisions wait for the captain, which decisions move automatically. That is the shape of a rehearsal, not a staged event, not a guaranteed hostile act. A rehearsal in the cold analytic sense. A chance for both sides to see what the formation becomes when a core layer is missing. For the defender, the lesson is brutal but useful. You cannot protect a carrier by assuming the picture will hold. You protect it by rehearsing what happens when the picture breaks. You protect it by making degraded command language shorter. You protect it by making cross-ship handoff faster. You protect it by making the first minute less ambiguous. You protect it by deciding in advance which assumptions die the moment the system goes dark. That is the difference between a 7-minute problem and a 7-minute opening. Now return to the unanswered question. Was this an accident or was it a rehearsal? The safest answer is that a technical accident can still function like a rehearsal. It teaches the crew. It teaches the command team. It teaches the escorts. And if anyone outside the formation is watching closely enough, it may teach them too. That is why the carrier did not only go blind for 7 minutes. For 7 minutes, the entire protective logic around it was tested. The public may see a short outage. A planner sees a compressed battle lab. An attacker sees a possible opening. And a defender sees the reason every second of recovery must be trained before the first missile is ever in the air. The first case is about blindness under pressure. The second is about slow strangulation. Put together, they show the same operational truth from two directions. A carrier is powerful because it can keep sensing, deciding, launching, recovering, refueling, repairing, and staying on station. Once any of those loops begin to break, the platform can still look invincible from a distance, while its real combat value is already sliding. You do not sink the ship. You strangle its lifeline. That is the real vulnerability hidden behind every aircraft carrier glamour shot. People imagine the carrier as a floating fortress. They picture armor, escorts, missiles, aircraft, and a wall of steel that can absorb punishment. But a carrier strike group is not a castle. It is a moving industrial system, and industrial systems do not have to be blown apart to be neutralized. They only have to be starved. If you want to kill the combat value of a carrier without firing the shot that makes headlines, you do not begin with the island, the flight deck, or even the escorts. You begin with the chain that keeps the group alive. Fuel, ammunition, spare parts, aviation maintenance, food, data, port access, repair windows, tanker support, The carrier is only the visible center of a much larger machine. The machine stretches far beyond the horizon. It runs to oilers, supply ships, logistics aircraft, repair pipelines, depot inventories, port cranes, dry docks, munition storage, and industrial lead times back on land. This is why the question is not only how hard it is to sink a carrier. The harder and more useful question is this: how do you make a carrier irrelevant? Start with fuel. A modern carrier strike group burns through fuel at multiple levels. The carrier itself may have nuclear propulsion, but the aircraft do not. The escorts do not. The replenishment ships do not. The helicopters, the strike fighters, the airborne early warning aircraft, and the entire screen around the carrier depend on a constant river of fuel moving toward them. Once that river slows, the group does not die dramatically. It shrinks. Aircraft sorties become more selective. Training events are trimmed. Patrol windows narrow. Alert posture becomes more expensive. Escorts begin balancing presence against endurance. Commanders start asking a different question with every operation. Is this mission worth the fuel burn? That is how strangulation begins. Not with explosion, with rationing. Now move to ordnance. A carrier group looks invincible when magazines are full, and aircraft can cycle through launch, strike, recovery, and rearm without interruption. But complex munitions are not magic objects that appear on deck forever. They are stored, transported, handled, assembled, inspected, loaded, and replaced through a chain that is slower than most people realize. Precision weapons are especially unforgiving in this way. Use enough of them in a sustained campaign, and the question becomes less about how many aircraft you have and more about how quickly the right weapons can be brought forward again. A carrier with aircraft but constrained munitions is still dangerous. It is just far less flexible. And flexibility is the real currency of carrier power. Then comes the part most people never see: maintenance. Carrier air power is not only built in factories. It is rebuilt every day by maintainers, inspections, cannibalized parts, workarounds, and constant labor under time pressure. Aircraft need parts. Catapults need service. Arresting gear needs confidence. Radar systems need reliability. Engines, hydraulics, avionics, cooling, and deck machinery all create their own demand signal. This matters because attrition does not begin only when bombs fall. Attrition also happens when replacement parts arrive late, when a valve cannot be swapped, when a deck system is deferred one cycle too long, when a maintenance burden rises faster than the logistics system can feed it. At that point, the strike group still looks intact from a distance, but readiness is quietly bleeding out behind the curtain. This is where ports enter the story. A carrier group does not live in open water forever as a completely self-contained universe. It depends on access, safe ports, friendly facilities, repair capacity, rearing nodes, political permission, reliable labor, secure shipping corridors into those hubs. Target the ports, and you do not even need to target the carrier directly. Delay access with missile threat, sabotage risk, mining, long-range surveillance, cyber disruption, or political pressure, and the operational map begins to tighten around the group. The carrier can keep moving. What it cannot do is regenerate at the same speed. This is the trick a serious red team understands. The carrier is not only a ship, it is a timetable, and timetables can be broken. Think about chokepoints, narrow sea lanes, predictable replenishment routes, known support hubs, high-value logistics ships that are easier to track, less defended, and often less politically dramatic to threaten than the carrier itself. Hit the oiler and the destroyer still floats, but the destroyer starts doing math. Threaten the replenishment lane and the admiral still has options, but each option gets more expensive. Force the supply ship farther back, and every gallon, every pallet, and every maintenance cycle takes longer to reach the group. You are not destroying the center of gravity in one moment. You are surrounding it with friction until it cannot express combat power at the rate it was built for. That is what people miss when they talk only about anti-ship missiles. Yes, a direct strike is dramatic. Yes, a carrier can be overwhelmed in theory by layered attack, but there is another path that is slower, quieter, and in some campaigns more realistic. You pressure the support architecture until the carrier becomes a symbol that can no longer act like one. The air wing flies less, the escorts stretch wider, the commander saves missiles, Maintenance backlogs grow. Refueling windows become critical events. Port calls become political crises. Every operational decision starts carrying a hidden logistics tax, and eventually the strike group is still present but not dominant. That may be enough. A navy does not always need to destroy the carrier if it can deny what the carrier is supposed to do. Deny tempo, deny reach, deny persistence, deny confidence, deny the easy assumption that the group can remain on station indefinitely and keep generating combat power at will. This is why logistics warfare is so dangerous to prestige platforms. Prestige depends on visible strength. Logistics attacks undermine invisible strength. By the time the weakness becomes visible, the damage is already deep inside the system. And once a commander starts conserving fuel, stretching maintenance, or guarding the support chain more aggressively than the battle space itself, the logic of the campaign has already changed. The carrier has not been sunk, but it has been cornered. That is the kill without the killing shot. You do not always defeat the platform by piercing the hull. Sometimes you defeat it by making every mile, every launch, every recovery, and every day at sea cost more than the mission can sustain. That is not cinematic, it is worse, because it is methodical, and methodical pressure is exactly how major systems fail in the real world. The public sees the carrier, a planner sees the fuel graph, an adversary sees the route map. A red team sees the support ships, and a serious commander sees the truth. The deadliest shot may be the one fired at the logistics chain, not the ship. That is the larger lesson. A carrier does not have to be sunk in public to be neutralized in practice. If the picture degrades at the wrong moment, its timelines collapse. If the logistics chain tightens, its persistence collapses. In both cases, the hull is still there, the flight deck is still visible, and the symbolism remains intact. But symbols do not win operations. Reliable sensing, recoverable systems, fuel, ordnance, parts, crews, and time win operations. And that is where aircraft carriers really fail.